How's it going, everybody? And welcome to another installment of Whiteboard Wednesday. We will begin here.
The end result was that there was an average
My bad. We will begin here soon. Give everybody a couple minutes here to get in and start everything off. And all that good stuff that goes along with it. Hopefully everybody is doing well. It's been a busy week for me thus far, and I still have 2 whole days to go. So it's been, I'm actually looking forward to the weekend. Normally the weeks are pretty even keeled, but this week has been kind of a roller coaster. But that's good, because that means I'm busy and I'm getting stuff done and things like that. So good stuff. So, anyway, like I said, hope everybody's doing well. We're going to take a look at some, what did I say we were going to take a look at? We're going to take a look at high-level design and low-level design. So, I'll give everybody a few minutes to get in on the call, and actually I need to update my the title, because we're not actually doing this on Tuesday, we're doing it actually on Wednesday. So anyway, we will get into all that here in just a few minutes. So if you guys have any questions or comments, stuff like that, you guys want to, a particular thing you want to dive into, feel free to drop that into the comment section. Chat with me. I will be happy to dive into anything you guys want to chat about. But yeah, it's good stuff. So we'll wait here till probably 4 or 5 after to get into the topic of conversation. So I will give some updates while we're waiting. For those of you that are watching this in a recorded format, I do have some updates for the CCNP Encore and an RC workbook. I have been working on it. I am almost done with the deployment piece of it. I still have a little bit left to do, but it's going to take some time for that to finish up. I got to get the Colo data center here squared away, get that all stood up, and then the VPN connectivity from the medium sites back to the Colo and stuff like that done. And once that's in place and we're squared away, then I'll be able to walk through the verification process. So actually, just to kind of give everybody just a high level of what that's going to look like. So we have core deployment tasks and solutions. Then we're going to have advanced networking implementation, and then we're going to have verifications that go along with those things. So how would you verify that all the things that have been implemented and things like that? And then we're going to get, once everything's stood up and operational, then I will systematically break those operational configurations, and you and I will be tasked with going through and trying to figure out how to fix them. So it's really difficult for anyone to troubleshoot something if they don't know how it works under the out of the gate. So that's something that we're definitely going to be taking some time digging into. So the big thing that I feel like is going to be important, especially when we get into the video series that's going to accompany the workbook, is, and I'll leave this out for, I'll probably put a poll out there to figure out where we want to go with it, but I feel like I am going to need to spend more time in the advanced networking section and the troubleshooting sections, because that's going to be where the rubber really meets the road. So, and I can get into how you would structure your configurations and your deployment models and things like that. But there's going to be a lot that's going to go into it. So I'll work with that as time goes on. So that's going to be going on. And then one of the things that I will be doing shortly after this is done, I know I was talking about doing a CCNA workbook. That is still coming, but it's going to take a little longer than I expected because I really wanted to get this knocked out first. Because I have Cisco Live coming up here in a few weeks. So I will be, matter of fact, when I'm in Vegas for Cisco Live, actually I leave the first. I'm flying out, so I will be in Vegas on the 1st, and then I have sessions all week, and then the following week I'm staying out there for an additional week. So I'm trying to get as much of the Encore and RC workbook done as I can before I leave, so that when I'm hoping to have it done before I go to live, so that it's live at live. So when I'm out there, people will be able to buy it, and not directly off me, but it'll be available for download and things like that. So that's the game plan anyway. So I'm hoping over the next couple weeks I can get the rest of it done. Like I said, the majority of it is done. I do have some sections in here that need to be wrapped up, DHCP, some security stuff, and things like that. And then I have the advanced networking verification, so going through all the advanced networking implementation steps, verifying each and everything that we implemented, and proving out that everything is working. Because the intent of the book is to give everybody that is looking at the Encore and an RC as your certification journey to get your CCNP in enterprise. The goal is to go through and make sure that those you know how to implement all those technologies. This workbook is a known good configurations for those tasks that you're going to see on the exams. So with that being said, the process of getting everything stood up and working, and then going through the dedicated trouble tickets and things like that, and being able to interpret what the question is saying and stuff like that. And there was a question that somebody had asked me: how am I going to, when it comes to the tickets themselves, how am I going to structure that? And the simple answer to that is the tickets themselves will be broken in the same topology that we build everything out in. The only difference is the configurations that we break. When you're going through the troubleshooting section, there will be a dedicated download option for you for the ticket configuration. So literally there'll be like a notepad doc that's got the full configuration for every device, but it's going to break the config. And the idea is to when you're first going through it, to apply the configuration that's given to you for the troubleshooting section and apply that to all your devices, so that when you go through and start doing your troubleshooting section, that you'll have to actually try to answer the question. After you go through it a time or two and you get familiar with what is going on, then things will get a little easier for you, and you'll be that much quicker on it. And that's really the point, is when you start troubleshooting a problem for the first time, you don't know what the solution is. So it's your job to go through and try to figure that out. It might be as simple as configuring the VLAN on the port, or adding the VLAN back to the trunk, or enabling that network under EIGRP, or whatever the case might be. There's a number of different things that you can do to systematically break a network. And if you go through those systematically, then you're going to be really good when it comes to troubleshooting different scenarios. You're going to identify the problem, stuff like that. So the goal is to take anything that's a troubleshooting component in the NRC exam and have you guys be able to walk through it and figure out what the problems are. So it's a big topology on purpose, because the fact that there's a lot of moving parts and stuff like that. So the intention is there to get all that to work. Anyway, that's a lot of information, and I realize that. So hopefully it's worth your time and effort, and it'll be valuable to you once you get to that point. So with that being said, that's kind of where I have everything. And then once this is done, once I'm done with the Encore and RC workbook, then we're going to pivot. I'm going to jump down to CCNA for a little bit, get that done so that the CCNA workbook videos, CCNA stuff is done. And then I'm probably going to move on to service provider and start diving into the service provider platforms and going through that. So now there are going to be videos for the Encore and RC workbook. There will be a video series for that that'll accompany that. Same thing with CCNA, same thing with service provider and security. But I'm systematically working my way through all these exams and trying to produce content for all of them. So it's going to take some time, but eventually I will get there. So I just wanted to give everybody a quick update on how that's going to, at least my vision for how that's going to come into play. Hopefully that's something that you're going to find interesting and valuable, and you'll want to take advantage of that. So one of the things that I wanted to talk to you guys about is high-level design and low-level design, because there's from conversations that I've had with folks recently, it seems like there's a definite there's a blurry line in how that actually works. And so I wanted to talk a little bit about how do you design a network at a high level and then get down into the weeds in the low level design, the nuts and bolts of how things work and stuff like that, because it can be kind of challenging when you think about it. So, and this is more geared toward for the folks that are like, you might be a CCNA level or working towards your CCNP, that type of stuff, where you've never really designed or architected anything. So you're looking for that information on how to go through that process. So it can be a bit challenging, and so the goal here is to try to eliminate that as a challenge. So that is what we're going to talk about today and how that's going to come into play. So let's talk a little bit about it from the high-level design. So what is a high-level design? A high-level design is the strategic view and direction that a customer is trying to go in. So let's take this example here on the screen. So let me go ahead and pull out my pen tool real quick, and we're going to talk a little bit about how this works. So just waiting for the pen tool software to load. I might have to, it's already, oops. Show toolbar. Is it hiding? There it is. Hey you. Thanks for coming out and playing. Okay, so let's talk a little bit about how this goes. So let's talk about a scenario where a customer comes to you. I gotta close it out. It's not working quite right. A customer comes to you and says, hey man, we are looking to do a particular thing. Like, we want to modernize our network. And today we are, let's say that they don't have any SD-WAN in play. Okay. So what would that look like for them? Well, so let's talk about this from the high level. So today we have DMVPN, and we have a architecture where we have one hub, which is E2, and then we have a handful of spokes. Spoke 1, spoke 2, spoke 3, 4, and then 5, respectively. And what our goal is to move away from the traditional overlaid VPN construct, right? So if we draw a cloud here, and then we connect everything to the cloud like this, what that's going to basically allow us to do is it's going to be this one big subnet. So we'll say 172.31.1.0/24, right? That's your DMVPN subnet. And over that on that subnet and on all these locations, you're running some sort of encryption, IPsec VPN of some type. How that's configured is kind of irrelevant, but that's what's in place today. So the drawback to that is it doesn't give you a lot of flexibility in how you're going to do things. So can you do any type of application-aware routing? Not really. Are there ways to make stuff work? Yes, there is. So one of the common things that I see day in and day out is you could do some sort of what I refer to as the ACL-based QoS. And you might say, what does that look like? Well, you have an access list that matches on the source. You have an or extended ACL that matches on the source and destination subnet. It encompasses IP traffic, so both TCP and UDP. And then you leverage that ACL inside of your class map to set, that's called then by your policy map to set a particular QoS value, a DSCP marking. It could be AF31, it could be EF if it's voice. It doesn't have to be always voice. I do have customers that prioritize other applications that are more business critical. Voice is not always the top dog. And with a lot of architectures today, in the days of old, having a QoS marking for voice was the way to go about doing it. Nowadays, I'm seeing a lot of customers going to a cloud deployment for voice, whether that's Cisco Call Manager in the cloud, or they're going through a Ring Central, or some other type of cloud-hosted voice, where your VPN tunnels don't necessarily need to have the same level of marking that your internet connectivity would. So you can do ACL-based QoS, where you're matching a couple subnets in your access list, calling that through your MQC, your modular QoS CLI. So you create your class map, you match the ACL in that with a match any, and then you do a policy map that sets a DSCP value, and then you apply that policy map to your DMVPN tunnel in an outbound fashion with a service policy, and then you're able to affect some of the traffic that rides over the DMVPN tunnel, commonly referred to as per tunnel QoS. And it's worked great for a long time. The drawback to that is that there's no application visibility, right? You don't have any idea of what traffic is actually flowing through the network in that respect. So how do you take that and then leverage it? Like, how do you get application visibility? Well, one of the things you can do is turn on NetFlow on the router, and then if you have some sort of network monitoring tool, whether it's a SolarWinds or a PRTG or some other tool that's out there that allows you to ingest NetFlow data, so you would have visibility to what's going on in the network and be able to do something with it. So one of the things that I find interesting about doing that is, yes, you can get visibility of what's going on in the network. However, once you have the visibility, how do you leverage it, right? So can you go in and do things over DMVPN or in your network in general with the diff-serve model with the per hop behavior capability? You can in certain respects. So one of the things you could do is you could migrate your QoS from an ACL base over to, we'll draw an arrow down here, to NBAR based. And if you don't know what NBAR stands for, it's Network-Based Application Recognition. So if you turned on NBAR and used NBAR as your matching technique, so it's going to match well-known protocols, and whether that's HTTP, UDP, there's a bunch of different options out there for it. It can match on certain well-known application signatures, the 5-tuple match, your source and destination IP, source and destination port, and then the transport, whether it's TCP or UDP. So you can do that, and that's where NBAR is going to kind of shine, is you can do that, and then you can use an NBAR-based matching mechanism to do those things, and then take that data and start to leverage application recognition to do that, but you're still limited on that because of what NBAR does, right? The NBAR's functionality is somewhat limited in what it can do. So, especially on older routers. Especially if some customers still run ISR 4Ks, or they've refreshed some of their hardware to something newer, stuff like that. So the bottom line here is when you start getting into how you control the traffic. So one of the common things that I see with the customers that I talk to is they have some sort of cloud instance or cloud instantiation somewhere, whether that's the big three, AWS, Azure, or GCP. They've got the connectivity. So let's assume for just a minute that this right here is AWS. That's a horrible A, by the way. AWS, right? And so they have both, they have a BGP peering over MPLS to it, and they also have cloud on-ramp, right? So they can come in through internet or through private WAN. They have what is AWS, that Direct Connect, and I think Azure is Express Route, or I might have those flipped. I always confuse them. But one way or the other, you still have to get connectivity into your AWS VPC. So how you would go about doing that can vary depending on what the customer needs. But so how do you prioritize what's going to be going over to AWS? Well, with traditional connectivity, you're going to struggle with that. Excuse me. So you could have a GRE tunnel set up, or you could have Express Route BGP, and then you could hopefully get some sort of QoS markings in there, stuff like that. But your ability to send traffic out to the internet, because it's internet-based traffic and you want it to catch best effort and it goes out the internet pipe, there are ways of making the routing work, but that's where guys like myself come into play, and you almost need us to a certain extent to get that done, because we know how to make those things happen. So, but we also spent the time to learn how to do those things. So with DMBPN, you're kind of limited in what your feature set is, right? It's, routing specific traffic out a specific interface can be challenging. Can you force internet traffic to go out the internet pipe? Sure, just create a default route, point it out to your public next hop IP, and you're good, right? It's a very simple configuration option. Been around forever. But if you're looking at the configuration from the perspective of, hey, I need to be able to control what traffic goes to AWS, I need to control what traffic goes to Azure, I need to control what traffic goes out to internet, I need to be able to prioritize voice where it's important, and that can be a lot to take on, and especially if you don't have the means to be able to do that. You could be, are there ways of getting that done to a certain extent? There is, and you could do that through both ACL and NBAR based QoS. It's doable. The reality of it is, though, that the things that we did 10, 15 years ago are no longer sufficient enough for what we are able to do today. So how would you get this to the next step? Well, I just had a conversation with a customer in the very recent past where we came up with a game plan, very similar design. What we ended up doing is the high-level design was to take SD-WAN hardware, and I'm going to leave it like that, and we put it at every one of these locations. So we put, and I'll change the color to be orange. So we put SD-WAN hardware here, 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 and here. We took 4 sites that are rather important to the customer, and what we did is provided that those SD-WAN hardware devices access to the internet, so that we could have it call home, so we can manage it from our command and control center, and then on top of that be able to set up the SD-WAN connectivity. So what we ended up doing is we built out an SD-WAN infrastructure in parallel. So we build this out like so. And what that allows us to do then is then once we have it built out, we can then selectively send whatever traffic we want from the customer site over to SD-WAN and vice versa. So the benefit to that is we get to test both the capabilities of SD-WAN and show the customer the power of what we do, right? So that was really the benefit. And we let that usually run for 60 days, 90 days, something like that, so they can get a feel for what it is that we're trying to do. Now that's the high level design, right? I've spoken nothing about the actual what technique would you use in order to send traffic from the existing hardware over to the SD-WAN hardware, so these are some of the things that we end up seeing, that when you're talking to the customer at a high level, you don't get down into the weeds because of the fact that it's high level. So there's a comment here. What are you seeing customers use for voice video now? Is it mostly through collaboration programs such as Jabber, Skype, Zoom, programs to that, since it lives on the computer? Is it HTTP, HTTPS traffic? So to answer your question, Matt, I see a lot of customers leveraging collaboration tools. A lot of customers use Microsoft Teams, and it's almost always going to be HTTPS at this point. So whether they're using WebEx or they're using Ring Central or they're using Microsoft Teams or Skype for Business, I see all of those. I don't see as much Zoom or Jabber, but I definitely see Skype. I definitely see WebEx. I definitely see Cisco WebEx, and I definitely see a lot of Ring Central. So so in that respect, because it is mostly HTTPS, that's what I see, and that's what I end up having to work with. So, but the cool thing about it is the application visibility stuff that's out there today is able to differentiate between, even though it's HTTPS going to port 443, it's still able to discern Zoom from Skype, from Jabber, and things like that based off of how the packet is built. So, so there is flexibility there. So, yeah, I very rarely, I still see to talk to customers that have on-prem like Cisco UC on UCS, and they're looking at doing hosted cloud, or hosted voice. It just, they have things going on. They're working towards that. So, I'm curious to know what you see. And there's another comment in here. Hi Rob, just wondering, how does BGP default originate work, and how does it differ from default route? I also stumbled with OSPF default originate as well. Not sure if that's the same with BGP. Okay, cool. It's not routing based on protocol, but yeah, Matt, exactly. It's based off application, and that's really the power of SD-WAN where it comes into play. So going back to Ken's question, so you have, let's break this down real quick. So you have BGP default originate. I am horrible sometimes at writing. Default originate. Then we have just a regular default route. Default route. And then you have OSPF default originate. So let's break these down real quickly, just so that everybody's on the same page. In order for OSPF default originate to do its job and originate a default route already has to be in the routing table. So, and that actually applies to all three of them, except for the regular default route. A default route is simply, let me draw it down here so that it's easier to see. A default route is this guy. It's all zeros, right? There's no other longer match route. So if there's nothing longer match in your routing table, send it to this guy, and he'll figure out where to send it from there. He'll send it up to wherever he's got to go. So that's where this comes into play. Both with BGP default originate and OSPF default originate, you need to have this route in your routing table already. So it can either be statically configured, meaning you manually type the configuration in on the router, and then you can pull these in, through OSPF or through BGP, or you learn it dynamically. Either way works. It's just a matter of you have to have the default route in your routing table in order for that to work. So then BGP default originate is just that. It's you're going underneath BGP and you're pushing a default route. Same thing with OSPF. You have a OSPF implementation and you want to push OSP default route into your environment. You can issue a default route, default origination through that. That's really that's really it when you think about it. There's really not too much more to it than that. So as long as you understand that, you're in pretty good shape. As long as there's a default route in the routing table, both BGP default originate and OSPF default originate will both propagate a default route into their respective routing domains. So if you have any more questions on that, feel free to drop it in the chat. But so I'm going to switch back over to my topic of high level versus low level design. So the customer liked what we did up here with SD-WAN, right? We have our SD-WAN infrastructure in place. We have our IPsec VPNs built between all these locations. We have the connectivity in place, and we're able to send traffic to the customers, the SD-WAN environment that we stood up, and have the traffic go where we want it to go. So how do we get them from, or what is the goal, or what is the method, I should say, what is the method that you would go through to get somebody from off DMVPN and onto SD-WAN? And the answer to that question is it's multifaceted. There is no one way to do it. There's multiple ways to get them there. It's just a matter of understanding what they've got going on. So one of the key things that I always talk about is, for example, is if we're talking about a scenario where spoke-to-spoke communication is still very prevalent and is happening on a regular basis, then that can impact how your migration process might look. If you have very little, if any, maybe there's no spoke-to-spoke communication, then that's a different story. Now, going back to what Matt asked about with collaboration tools and voice and video today, that doesn't follow the same paradigm that it used to. So when I talk to customers about how we would migrate them from their existing WAN infrastructure over to SD-WAN and get them where they want to be, and I ask them about spoke-to-spoke communication, the only thing that I don't really worry about, especially if they're already on a cloud-hosted voice solution, Cisco WebEx, Microsoft Teams, or Ring Central, or whatever it might be, that doesn't follow the same routing paradigm that your applications are going to follow because it's already cloud-based. So if your call manager is already in the cloud, so if I pick up the phone and I dial an extension, I'm expecting to call Mike in the cube next to me, or in the, he's works in a room opposite of me, or whatever the case might be. That when I pick up my phone, I dial his extension, then that goes out to the cloud provider call manager, and then redirects to his phone. His phone rings, and then there's a point-to-point connection set up between my phone and his phone, and we're able to talk. Same thing happens when I'm here at home and I need to talk to somebody through Cisco WebEx. All of my connectivity shows up in the cloud, and if somebody calls me, that's a direct point-to-point connection. And the reason why I know it's that is because I have had people call me, my cell phone lights up because I've got Cisco WebEx on my phone for work, and people will call me, I will pick up the phone call on my phone, and then I'll get back to my office, and I'll be in front of my computer, and I can't, unless I hang up the phone with them, I can't pull up a typical bridge WebEx is different than that, where you're on an audio bridge is not the same thing as a phone call. So some things to keep in the back of your mind when you're understanding how application flows work. So when I talk about migration, I'm talking about not so much spoke-to-spoke voice, which is important, but as long as there's internet connectivity, it's usually not a problem. When we talk about in a situation where there is no spoke-to-spoke communication, it makes the migration very, very easy, because now all you have to do is at the hub location is give the, you can usually just do a cable swing cutover. When there's no spoke-to-spoke communication that's necessary, it makes it very, very easy. All you have to do is cable swing the existing infrastructure from the DMBPN environment over to your SD-WAN equipment, and you're in good shape, right? It makes the things very, very simple. What about the scenario where there is going to be spoke-to-spoke communication and you need to keep that enabled? Well, the simple answer to that is on your hubs, you would join the hubs together, whether that's OSPF, BGP, whatever the case might be, and you would allow the routing propagation to happen between the two of them. So that in the event that you've got somebody at a remote site that needs to talk to somebody else at another remote site, but one is on SD-WAN and the other is on DMBPN, simple. You have your SD-WAN traffic come in on your hub, and then it rides over this connection over here to your DMBPN hub, and then that rides over to your remote spoke that needs to talk. As long as spoke 1 and spoke 2 know how to reach each other, then you're in good shape. That's really all that matters. And so whenever you're talking about migration strategy and how you would do that, as long as you have hooks into both the old and the new system at the same time, and there's route exchange, that's all that matters. Now, are there complexities when it comes to taking down something that's on SD-WAN? That was on DMBPN, that's now on SD-WAN, and that DMBPN spoke goes away? Yes. The key thing is going to be the connectivity up here at the hub. You need to make sure that both environments, both your SD-WAN and DMBPN environments, are able to communicate with each other. If they're able to communicate, that allows you to take whatever steps you need to. And then you can systematically remove all the capabilities that you're trying to implement. Yeah, thanks, Mario. I appreciate that. That's what I'm here for, man. I do my best. So that's a real world use case that I'm working with a customer on right now, and that's something we're in the process of going through. And they were very apprehensive at first when we brought up what we were trying to do, and rightfully so. And I was just like, you know what? If I was you, and I was sitting in this chair, sitting in your chair, and you were me, and I was you, and I was telling you all these things about what we're trying to do, I'd be a little worried about how this is going to get pulled off. But here's the reality of it. It's once you understand how the architecture works and how the nuts and bolts operate, what's interesting is a lot of these solutions are very easily transferable from one to the other. DMBPN and SD-WAN work very, very similar to each other. A lot of the same core concepts and core capabilities and components are in DMBPN exist in SD-WAN. Really the only difference is the orchestration, or it comes into play with the automatic VPNs being stood up and getting the connectivity where you need it to be. All of those things that would normally be complicated and you would need someone like me to come in and stand up a bunch of stuff to get it working. A lot of that complexity goes away when you move over to a orchestrated mechanism to do that. For example, for anybody that has watched my SD-WAN series on Viptela that I did a while back, I pointed it out multiple times during the stand-up that I didn't have to configure a single IPsec VPN. It was all done in the background for me. I didn't have to do a thing, because that's the whole point of doing an SD-WAN deployment, is getting all these logical connections built over the top and all that type of stuff, because when you when you know how that stuff works at the ground level and you worked your way up to understanding it at the top level, when you are introduced to a system that does things a little bit uniquely, like for example SD-WAN, it's easy for you to wrap your head around because you're already familiar with how other technologies have done that, and you've gone through it the manual way. So, and if you don't have that experience, and that's a lot of people don't have that experience. That's why folks like myself have the positions that we do, because I go in and I whiteboard this exact same design. Well, a very similar whiteboard session is what I had with a customer, and once I drew it out for them, they were like, "Oh, okay, now I see it," But that's why there's guys like myself and lots of other really talented engineers that become solutions architects because we understand how all this stuff works. Network guys under the hood, right? We are all about getting IPs to talk to each other, but at the end of the day, it's about the connectivity. So let's transition over to the low level discussions. So the customer is talking about how they want to get this implemented. So how would you go about doing that? Well, what would be your mechanism to do that? So, and there's no one answer. There's no right way or wrong way per se. There is, how do we get that traffic to be where we want it to go? And the answer to that question is, it depends on the needs of the business. So I was having a conversation with a customer this week, and I went through and I was going through the discussion of how we would go about doing stuff, and the bottom line really comes down to, we need to determine what you guys want to do. It's easy to stand up the hardware, right? It's easy to send hardware to a location and give it some connectivity and some IP addressing and things like that. That's the low-level design usually is left to the folks that are going to be responsible for the implementation. So there's usually, especially in the Cisco partner world, there's a very clear delineation between high-level and low-level design. High-level comes up with, we're going to go and we're going to deploy SD-WAN. We're going to use these boxes because that's what's necessary for either bandwidth or user capacity. It's been right sized based off of the customer's needs, right? That's the high-level design, and that's what's been figured out. And that's usually where the high-level design will stop. They will take the information and they will pass it on to low-level, and it'll be low-level design's job to go in and figure out the nuts and bolts. What are we connecting into? What's the IP addressing going to look like? What routing protocol are we going to use to connect all this stuff together? What is the criteria that we're going to be using to send traffic over this or over that? So I used to do this a lot with Nexus 9Ks, VXLAN, migrating from legacy environments over to Nexus 9Ks. And once we figured out, once I and a couple of other engineers figured out how to get some stuff moving, we got ourselves in a good spot, and we were able to replicate a lot of design relatively easily, and that made it really easy to do migrations for customers that would stay in flight for a while. Matter of fact, I had one customer where I walked into their environment, and when I left their environment, they were still in a migration stage, and that was just about 3 years, because they were already on an architecture, and they had started moving stuff over, but it was a very slow roll because of the applications, the customer that they were, the needs of the business. They couldn't move things very quickly. It wasn't like we were able to get something stood up and then do a hot cut and boom, you're good to go. Customers like being in migration stages or in a migration state long enough to where they can move things over at their speed. And that's exactly what they did. So when we talk about the capability of moving to going from high level to low level design, some things need to be figured out. Like, okay, how do you get public IP addressing to things? What do you, connectivity wise, how would you go about doing this? How would you go about doing that? So one scenario that comes to mind is, I have an SD-WAN edge device, right? and we'll say this is the outside, and we'll say this is the inside. So I'll put O for out, and I'll put I for in. Well, we have internet connectivity here, and then we have LAN connectivity here. The question is, that's the high level. How do we get their existing infrastructure that is also connected here? So we'll just put EI for existing infrastructure is also connected to those same things. How do we get the LAN traffic from that's actually flowing this direction today? How do we get a subset of that traffic over to SD-WAN? That's the question. And the answer to that question is it depends. So one way we could do that, and I'll walk you through some high-level ideas, is we could, on a port on this device, we get a point-to-point /30, and we do policy routes. So you come in here and you do some good old-fashioned PBR on both sides. You send whatever traffic you want over to SD-WAN, and SD-WAN takes that traffic, sends it over the wire to wherever it's got to go, and then it's received on the remote end, and you do the exact same thing in the reverse order. You PBR it from your existing infrastructure to the SD-WAN box, and you go about your day. Maybe it's a BGP thing where you set it up to where you do local preference or an AS path prepend or community value or longest match routing, something along those lines where you get somehow you send the traffic to SD-WAN so that it gets where it's got to go. And you do that long enough to where you're in good shape. Now, some customers are more, how do I word this? Some customers need more care and feeding than others. Some customers are cool with you just doing a shut and a no shut. And then you just swing it over to SD-WAN and you're done. Right? They're comfortable with doing a cable swing. There is no right answer. There is no wrong answer. The scenario is what type of downtime can you occur? Okay, we can't incur any downtime. So you need to take those things into considerations when you're talking about how the long-term effects will come into play. So what do? Well, that's a conversation for you and the customer to have. So it's not always going to be a straightforward conversation. Sometimes you might need to, and I've done this plenty of time, where I've been on a call with a customer and I will have to pull up Visio and share my screen, and then I will have to walk through what I think we should do. And there's going to be conversations that are going to get really in-depth into the weeds, how the connectivity comes into play, how you get traffic from point A to point B. So going back over here, if you need to be able to give your SD-WAN box and a public IP address so that it's able to get out to the internet, so that it can go check in with its portal, how would you do that? You may not have any available public IPs to give. Well, the answer to that question is you might have to do a NAT. You might have to NAT that traffic. So, like I said, there's more than one way to skin a cat. It's just a matter of figuring out which way is best for that particular scenario. And like I said, and I've mentioned this multiple times, you have best practice, right? Best practice is going to take you a certain distance in your deployment model. Unless it's a greenfield and you're able to do whatever you want. But in most cases, best practice is going to get you to a certain point. And then at some point in that life cycle of that deployment, best practice is going to hit a brick wall, and you're going to have to break away from best practice. And you're going to have to figure out, how do I, with the capabilities of this device, how do I get my traffic to where I want it to be? And that's where the engineering comes into play. With the more you know, the better off you're going to be. The more techniques you know. It's like, the jiu-jitsu guys that I know, they're like, well, the more techniques you know, the more likely you are to tap somebody out. That's the logic. Doesn't always work out in practicality, but that's the bottom line, right? So you may not know how to fix this. So, Or if you do, great. Then you're able to like, well, we could PBR the traffic or whatever the case might be, and get it to where you want it to go. So these are some things in the process of getting into the low level design that you would need to figure out. So how much information would you need to know in order for you to be able to make that decision? You would need to probably know quite a bit. You would need to know what hardware you're dealing with. You would know how it's connected, how many ports are available. Is the customer willing to give you a subnet that's open in their environment to get you where you want to be? You know, the customer is going to have to give a little to get a little, and so, but that's going to be a common understood process. There can be complexities, and the one question I get a lot is, how do you guarantee that it will never go down? And the answer to that question is, I never guarantee that. I never guarantee we won't have any problems. What I do swear by is we'll do our best not to have any problems. We'll do our best to make sure that when we're looking at the implementation, we've got all the right people looking at it. We'll have the customer looking at it because they know their environment the best. We'll have our team looking at it, and we'll be pulling in anybody that we need to could potentially need to answer that question, because the whole point of high level design, low level design, and implementation is to mitigate as much risk as you can, right? Mitigate downtime. So maybe downtime is, an hour and a half is acceptable. Well, if you actually hit that timer when you're doing a migration, it's not going to make you look very good. So, but the key, one of the things that I learned a long time ago is the first 3 to 5 sites that you do try to flip over and get working and get stood up, those are going to be the most problematic. Why? Why would they be the most problematic? Well, because there's going to be specific aspects of the deployment you haven't figured out yet. There might be something that the customer engineer overlooked or forgot about, or the guy doing the implementation didn't know that capability existed, or whatever. Throw any one of 1,000 potential things at it, but that's why you always have some grace thrown at you when it comes to doing these, because there's going to be some sticking points, learning curves, things like that you'll have to go through to get you over these little humps. There's going to be some growing pains, but you'll figure those out, and then you'll get much more efficient with it as time goes on. And then from the time that you get to that point, you'll be able to get into a groove, and you'll be able to come up with in the partner space, we call it a MOP, method of procedures. So you'll be able to lay out, we're going to do this, and this in this order, and once that's done, you guys should be good to go. And we've done it at these other sites that we've done them the exact same way, or this is the order we've come up with, and you apply that logic, you go through that flow, boom, things are working great. Okay, cool. Now we've come up with a game plan, and so you replicate and you repeat things that you figure out and processes that work until the customer is completely migrated and you're in a good spot. So these are some of the things that network engineering is full of. I don't want to break it. It's actually sometimes a good thing to break stuff, because then you learn from that, and that's part of the experience of being an engineer, is trying things to see what's going to work. There's an analogy where you throw stuff at the wall to see what's going to stick, and then once it starts to stick, then you know what you can work with. And so that's kind of the same logic here. So that's pretty much what I wanted to chat with you guys about tonight. So high level design, low level design, things like that, how you get from point A to point B and stuff like that. So if you guys have any questions or feedback, you can throw that into the chat. I'm going to I know I've been talking for a little while now. I've had some commentary in the chat. So if there's anything specific you guys want to talk about, feel free to drop that in the chat. I'll give you guys a minute to put that out there. But enjoy you guys hanging out with me. Want to thank you guys for showing up and hanging out, making it to another Whiteboard Wednesday. But if you guys don't have anything going on, we can probably cut the call a couple minutes early. But I figured I would just throw it out there. If there's something specific you guys had a question on, we can always dig into it. Try to help you guys out. So, but other than that, that's pretty much what I have for now. It's good stuff. I always say that if you don't learn at least one thing new a day, then you're kind of wasting your time. So, anyway. Doesn't look like there's going to be anything in the chat, which is fine. Don't feel pressured to throw anything in the chat if you don't want to. But if there's yeah, at some point, can we talk about your all-time fave for a topic? Okay, a couple of comments. At some point, can we talk about Irfan? You talking about like my all-time favorite technical topic? Is that what you mean? I'm pretty sure that's what you mean. And then Peter asks, what exactly is the difference between hardware throughput on a router and the bandwidth on the router ports? Oh, okay, yeah. CCIE is dead. So yeah, we could talk about CCIE is dead at some point. I'm sure. I think it would be an interesting topic to talk about. Go out live and make that my banner. So Peter, to answer your question, what is exactly the difference between router or hardware throughput on a router and the bandwidth on the router port? Yeah, I know, Irfan, you're just kidding, but it's a good topic to actually talk about, because that's something maybe on the next Whiteboard Wednesday we talk about, is certification worth going after or something like that, not just make it, certification specific. We could talk about the certifications in general. So maybe that's a good topic to go through. So the difference between hardware throughput and interface or bandwidth on the router ports. So the simplest way to explain that, let's define both, right? I'm going to go ahead and clear my screen just so that we have a clear place to talk here. Let me go ahead and zoom out just a little bit so we have some space, and then I'm going to put out a custom shape here, and we'll dig into that because it's actually a legit question. So let's talk a little bit about that real quick. Okay. So let's first talk the first one. What is we have hardware throughput. What is hardware throughput? Hardware throughput, and we'll just take a router for the sake of argument. Hardware throughput is how much bandwidth the device at the platform level on all interfaces, input and output, can send and receive at the exact same time. So you have full duplex, all interfaces, sending and receiving traffic at the same time. That's what hardware throughput is going to be. So that's platform level, or what they refer to as aggregate bandwidth. That's what they mean. That is what that comes into play. So if the aggregate bandwidth of a device is 25 gigabits per second, and you have, for example, you have 8 by 10 gigabit per second ports, and then you have, say, 20 to 40 gigabit per second ports. I'm just throwing some numbers out there. That means that the total throughput of that box is 25 gigabits per second for all interfaces receiving and sending at the same time. So where you get bandwidth at the router ports is different. So the way you would associate that here is 8 times 10 is going to be 80 gigabits, and this right here is another 80 gigabits. So interface bandwidth capability is 160 gigabits. So the simple answer to your question is they're not the same, and they're very, very, very different. So if I have a router, and this is actually, I'm going back on memory of the ASR 1K platform was a great example of this. So you would have platform wide, you'd be able to do 25 gigabits a second at the aggregate on all ports sending and receiving, but you would have a module that you would be able to plug into the router that would give you two 40 gig interfaces, and then you'd have the onboard built in, like the back of your computer NIC would give you 8 10 gigabit ports. And I think there was another one where it was like 2 or 4 1 gig, something like that, for like LAN connectivity. So you would have interface ports, you would have a possible 160 gigabits per second at the port level. Well, if you do the math on that, and math is not my strong suit, so you're looking at a 1 to 8-ish, maybe a little lower than that, 1 to 7 disparity. So what that means is it's actually easier to understand if you look at it from a switch perspective. And you look at, this is an access layer switch, and typically access layer switches are going to have either a 2 or 4, like 10 or 25 or 40 gig uplinks. Now, at least nowadays. Back it used to be only gigabit back when I started. And then you have your downstream. So let's say we have a bunch of ports on here. These guys are all 1 gig. Well, if we have 48 by 1, right? And then you have, let's be generous, and we'll say this guy has got 4 by 40. So let's do some math on that. 4 by 40 is 160 gigabits, right? Where 48 by 1 is, well, 48 gigabits per second. So the question is, would I be oversubscribed at the port level, at the access port level on the switch? No, I wouldn't, because I'm looking at 48 gigabits of downstream bandwidth on a per port basis. So that's full duplex, so that's send and receive at the same time. All 48 ports send in 1 gig of traffic at a time, and you've got 4 40 gigabit ports. You would have what? 160 gigabits. So you would be well undersubscribed. Now, if it was the opposite of that, let's say we had 2 by 10, which gives me 20 gigabits per second. So I've got 20 gigabits of upload, but I've got 48 gigabits of downstream connectivity. Am I oversubscribed? Yes. It's a 2 to 1 ratio, 2 to 2.5, something like that, because I can only half of my, little less than half of my access ports are actually able to send at full line rate. Why do networking vendors do this type of stuff? Well, it's the logic of the likelihood of all 48 ports sending at line rate meaning we're going to be sending at full gigabit speeds 24 hours a day, 7 days a week, is very, very unlikely. What you're more than likely going to see is a substantial smaller amount of bandwidth than that. You might see 100 megabit or higher in a very, very short window period of time. Why is that? especially when you're talking user access switches where you've got a bunch of users doing stuff. Most user traffic is not that heavy. Web traffic, other types of application traffic that's on the network. But in the grand scheme of things, it's not going to be high bandwidth communications like you would see in the data center. Data centers are completely different, and the switches are purpose built for that. You would never put like a VXLAN fabric riding on Nexus 9Ks as your campus user connection. And the reason for that is because you don't need that kind of bandwidth. Where in the data center, you would have, let's say you have spine 1, spine 2, leaf, we'll do leaf 1, leaf 2, and leaf 3. And each one of these guys is connecting up to the spine at 100 gigabit. Well, if you've got 100 gig here and everywhere across the board, you're going to have 200 gigabit per second, which is a very common speed that I've deployed. 200 gigabits per second going upstream, and then on a 48 port switch at 10 gigs per second on a typical server connection, you got 48 by 10 gives you 480 gigabits per second. Are you still oversubscribed? You are, but not to the same level you are over here, because even though the bandwidth at the interfaces is higher in the data center because of its server traffic and its east-west, a lot of stuff going on, the numbers will scale. They'll be basically the same. I've just added zeros to these numbers, so it'll be actually more like this. But that's acceptable in the data center because of the east-west communication and things like that, where you would more than likely have the need for that with storage, replication, users accessing servers. Is that going to be consistent though? No, it's not going to be consistent. Is it going to be frequent? Yes. Is it going to be all day, every day? More than likely, no. So these are some things to keep in the back of your head when you're looking at aggregate throughput, or what you mentioned on hardware throughput versus bandwidth of the router ports. So hopefully that answers your question, or at least provides you some clarity on that. So if not, you can ask for specifics or where you're getting hung up, and I could try my best to try to answer those. But so basically, when I'm planning for a site, I should look at port density for connections, but hardware throughput for the actual load bandwidth. Yes. So if you are if you're planning hardware, you need to be looking at what's going to be attaching to the hardware. Going back to my user connections over here, I would suspect you're going to be looking at 5 to 25% utilization on a per port basis throughout the day. That's going to be your 8 o'clock in the morning until 5 o'clock at night is going to be your normal data usage. 5 being the more consistent one, especially when people are listening to music or doing their day-to-day job. That's probably going to be consistent bandwidth on the interface. That's going to be your user access switch. But if you're talking data center, I would automatically assume higher. Yeah, it can definitely be a catcher, but there are cases where not necessarily. Now I'm talking a small spine deployment. I've had customers that have gone spine 3 and then spine 4, and they are 100 gigs, and I'm looking at 400 uplink, and I'm looking at 480 downstream, and it's basically a 1-to-1 ratio. Like, I can give a server a full dedicated 10 gigabit per second all day, every day, and never even have to blink an eye because the upstream bandwidth is there. So as long as you're down, if you can get them as close to 1-to-1 as you can, you're going to be, that means you're going to be in a good spot. But the likelihood of you seeing that on a regular basis, very, very unlikely. At least that's my experience. But if you have any questions on that, you're probably connected with me on LinkedIn. So just feel free to drop me a line there, and if you've got a question, I'll be happy to try to answer for you. Or comment on a video, and I'll try to respond to it respectively to whatever it is. So cool, guys. I'm glad you guys were able to throw out some more comments and all that good stuff, and hopefully answer some questions and provide some insight. So got a few more viewers in than I was expecting to, which is always a good thing. So if I'll give you guys another minute. If there's any other questions or anything like that you want to chat about, throw it in the comments and I'll handle them as they come in. If not, I will let you guys go back to your regular scheduled evening stuff. I'm gonna go knock out a workout. So it's been a busy day for me and I need to blow off some steam. So, but other than that, that is pretty much all I have for you this evening. So good stuff. Thanks again for showing up and hanging out with me on Whiteboard Wednesday. It's always a good time. So if I don't get anything in another 30 seconds, I will bid you all farewell. Excuse me. All right. That wasn't quite 30 seconds, but there's nothing popping up in the chat. So, all right, ladies and gentlemen, for those of you that are still here, I'll see you guys next week, same time as normal. I will update the title to not be Tuesday. It'll be Wednesday, unless something comes up. I do know it's summertime coming up. I will be less in front of the computer and more outside because, well, I like the sunshine as much as the next guy does. So, hopefully I'll be able to enjoy it a little bit more this summer. Not stuck in front of the computer all the time. Anyway, with that being said, you guys have a good rest of your night, and I will catch all of you guys next Wednesday. Have a good night, everybody.